What if I told you that some of the most revolutionary machines in human history were never built in a sleek laboratory or a Silicon Valley garage? They were built in muddy forests by rough-handed mechanics with nothing but a problem to solve and steel to bend. 10 logging machines showed up that the world simply wasn't ready for. Machines that rewrote how entire forests were harvested. Machines so far ahead of their time that the major manufacturers scrambled to copy them. These are their stories. Number 1. The John Deere MC Crawler. Let's start right at the beginning of our timeline, 1949, and with a machine that most people have completely forgotten about, even though its DNA lives inside almost every piece of forestry equipment built since. In 1949, John Deere introduced what they called the MC Crawler. Now, on the surface, a crawler tractor doesn't sound revolutionary. But what loggers did with this machine, and what John Deere recognized it could do, changed the direction of forest mechanization entirely. Before the MC Crawler, pulling logs out of steep terrain, soft ground, and near impossible slopes was done with horses, oxen, or older steam-powered systems that were dangerous and unreliable in wet and icy conditions. The MC Crawler gave loggers a diesel-powered, track-driven machine that could handle these environments with a stability that wheeled vehicles simply couldn't match. Loggers across North America started modifying these crawlers immediately. They removed wheels and seats, attached wooden skids to the front, and ran the machine as a stationary winch. That improvised adaptation, using a crawler's powertrain to haul logs, was the seed of the modern skidder. John Deere recognized the MC Crawler's reputation and praised it specifically for its performance on steep slopes and in soft soil conditions, two environments that had always been the greatest danger zones for logging operations. By 1957, John Deere built on that legacy with the 440 crawler, which introduced a hydraulic blade mounted inside the cab, a comfort and control feature that was genuinely advanced for its era. This was the machine that paved the way for the company's switch to all-yellow forestry equipment in the following year. The MC Crawler matters not because it was perfect, but because it was a proof of concept. It showed the industry that a reliable, track-driven machine could replace animal power in the most brutal corners of the forest. Every tracked logging machine you see working today carries its lineage. Number 2. The Garrett Tree Farmer Skidder. Here's a machine that was literally sketched on a napkin and then went on to be copied by John Deere and Caterpillar. In the early 1950s, a man named Dwight Garrett from Enumclaw, Washington, had an idea during a coffee break. He sketched out a concept for a new type of logging machine on a napkin, handed it to his chief mechanic Mike Nanovich, and together they built what became known as the Garrett Tree Farmer, the world's first rubber-tired, articulated logging skidder. Let that sink in. Articulated steering on a logging machine, where the entire frame bends in the middle rather than using traditional steering wheels, was a concept that engineers at major equipment manufacturers hadn't brought to production yet. Dwight Garrett got there first. In a small shop on Roosevelt Street in Enumclaw, the Tree Farmer was powered initially by small Ford gasoline engines. It used a short arched boom at the rear and flexible rubber tires that allowed it to maneuver around stumps and through second-growth timber in ways that tracked machines simply couldn't. Unlike the old crawler-based systems, the rubber tires caused far less soil compaction and damage to young growth, which made the machine not just faster, but ecologically superior for its era. The Garrett Tree Farmer was manufactured not just in Enumclaw, but also in Gothenburg, Sweden and Toronto, Canada. A remarkable global footprint for a machine designed in a small-town machine shop. At peak production, Garrett Enumclaw employed 87 local workers, and buyers came from as far away as South America and Russia to acquire these machines. And then the big players noticed. John Deere, Caterpillar, and others began producing their own articulated rubber-tired skidders in the late 1960s, using the design philosophy that Garrett had pioneered. Franklin eventually purchased the Tree Farmer brand itself in 19... The machine's design was described at the time as recognized worldwide as revolutionizing the logging industry, and that assessment holds up completely. Articulated steering is now the universal standard on logging skidders. It started on a napkin in a coffee shop in Washington State. Number 3. The Prentice Hydraulic Knuckleboom Loader. In 1945, Leo Heikkinen opened a small machine shop southwest of Prentice, Wisconsin. For over a decade, he watched loggers struggle with a problem that seemed almost embarrassingly basic: loading logs onto trucks. At the time, loading required at least 3 people. An A-frame rig made from 2 leaning poles, cables, rigging, and a system of hooks that demanded coordinated manual labor just to lift a single log onto a truck bed. It was slow, dangerous, and wasteful. Heikkinen spent years engineering a better solution. By 1956, he had built the world's first hydraulic log loader and named it after the village where it was born, Prentice. His design featured a jointed boom arm, the knuckle, driven by hydraulics, with a claw-like grapple at the end that could grip and swing logs with one operator controlling the entire process from a single seat. This was the birth of the Knuckleboom Loader, a design so effective that it captured 51% of the worldwide market and is still the dominant log loading technology used today, 7 decades later. Before Prentice, loading logs by hand required a team of workers and elaborate rigging setups. After Prentice, a single operator sitting in a cab could load a full truck in a fraction of the time with dramatically improved safety. It wasn't an incremental improvement, it was a complete replacement of the old system. Heikkinen incorporated his operation as Prentice Hydraulics Inc. By the late 1960s, the company was producing over 1,500 machines annually. He sold the business to Omark Industries of Portland, Oregon The brand eventually passed to Blount Inc. and then to Caterpillar in 2007. But every knuckleboom loader working in every forest on Earth today follows the design logic that Leo Heikkinen worked out in a small Wisconsin workshop in Number 4. The Timberjack 200 series skidder. In the 1950s, 2 engineers named Wes McGill and Robert Simmons were working in Woodstock, Ontario, Canada. They had an idea: build an articulated 4-wheel drive tractor with a winch mounted at the back, a purpose-built machine for pulling logs through the forest, not a converted farm tractor or a jury-rigged crawler. They built a prototype. It worked. And from that prototype came Timberjack, one of the most influential forestry equipment companies in history. The Timberjack 200 series skidder, released in the early 1960s, was the first articulated skidder to officially carry the Timberjack name. It ran on a 61-horsepower Ford gasoline engine and had a suggested retail price of $8. To modern ears, that sounds modest, but what this machine represented was enormous. A purpose-built, commercially manufactured, articulated cable skidder designed from the ground up for forest conditions. Before machines like this, skidding logs out of the forest involved wrapping cables around individual trees by hand and using crawlers or winches to drag them to a roadside. The Timberjack 200 made it faster, safer, and more systematic. Timberjack grew into a global brand owned at various points by Eaton Corporation, Rauma Rapola of Finland, and eventually John Deere, which purchased the company in December 2000 for $570 million. That acquisition made John Deere the single largest forestry equipment manufacturer in the world. The 200 series skidder was the machine that launched all of that. It was a practical, rugged, articulated workhorse that proved the concept of the purpose-built cable skidder when everyone else was still thinking about converted farm equipment. Number 5. The John Deere 440 cable skidder. By 1965, rubber-tired skidders existed, but they were rough. Garrett had proven the concept. Timberjack had commercialized it, but the machines were still essentially an engine bolted into a frame with 4 wheels and a winch. Operator comfort was an afterthought. Safety was almost non-existent. The cab, if there was one, was open to the elements. John Deere changed all of that with the 440 cable skidder in 1965. The 440 introduced something that seems obvious in hindsight but was genuinely innovative at the time. It treated the operator as part of the machine design. Ergonomics, seating, controls, and operator visibility were built into the 440 from the start, not bolted on as an afterthought. The result was a skidder that was not just more comfortable to operate, but measurably more productive because tired, uncomfortable operators make poor decisions and work more slowly. The 440 ran on 59 horsepower and included features specifically designed to keep the person behind the controls safe and effective over a full working day. It brought operator comfort into the equation to increase safety and productivity, and the industry took notice. By 1973, John Deere followed the 440 with the 740 Skidder, built with 145 horsepower, blade options, and a best-in-class grapple. But it was the 440 that set the standard, the first skidder to treat the operator as a design priority, not an afterthought. This philosophy, designing equipment around the human being operating it, was ahead of its time in 1965, and it became the engineering standard for every serious forestry equipment manufacturer that followed. Number 6. The Drott track-type feller buncher. By the late 1960s, the logging industry was facing a labor crisis. The post-war economic boom had given workers options they didn't have before, and many of them chose options that didn't involve standing in a forest with a chainsaw at 6 in the morning. Loggers were hard to find and expensive to keep. Into this environment came a man named Drott, and he fabricated a machine that historians now credit as the first track-type feller buncher. The concept was radical. Instead of a crew of chainsaw operators felling trees one at a time, a single machine could drive up to a standing tree, grip it with hydraulic arms, sever it at the base, and hold it, then move to the next tree, and hold that one too, accumulating multiple felled trees before depositing them in a neat bunch for the skidder to collect. A single feller buncher could potentially do the work that previously required 10 to 15 human beings with chainsaws. And it could do it continuously without fatigue in conditions that would send human workers home. Drott's late 1960s track-type design established the fundamental concept. Caterpillar then introduced tracked feller bunchers based on their 225 series excavators in 1973, giving the design industrial scale and durability. The tracked configuration was particularly suited to soft and uneven ground, the very terrain where manual operations had always been most dangerous. The feller buncher didn't just speed up logging, it fundamentally restructured the workforce and the safety profile of timber harvesting. Drott's initial fabrication was a direct response to a real-world labor problem, and the solution he built was so effective it became the template for an entire category of machine that remains essential today. Number 7. The Hydro-Axe wheel-type feller buncher. While Drott's track-type feller buncher was a critical innovation, tracked machines have limitations. They are slower on flat ground, more expensive to maintain, and less suited to certain terrain types, particularly the relatively flat pine forests of the American Southeast. Carroll Nelson and Len Vicina recognized this gap and invented the Hydro-Axe, a hydrostatic wheel-type feller buncher that adapted earlier land-clearing mowers for timber harvesting applications. Where the tracked buncher prioritized stability and power in rough terrain, the Hydro-Axe prioritized speed and maneuverability in flatter conditions. It used a hydrostatic drive, meaning the machine's speed and direction were controlled by hydraulic fluid pressure rather than mechanical gearboxes, which gave operators unusually precise control over how the machine moved through dense stands of trees. The Hydro-Axe allowed operators to drive directly to individual trees, fell them without manual chainsaw work, and bunch them for collection, all in a wheeled package that could travel between work sites at road speeds rather than being hauled on a trailer. This machine became the dominant feller buncher in the American Southeast's pine timber industry. It defined an entirely different approach to mechanized felling suited to the specific conditions of plantation forestry: flat terrain, uniform tree sizes, high-volume production. Later, the Hydro-Axe brand was acquired by Blount Inc. and eventually rebranded under the Prentice name by Caterpillar in 2006. But the wheel-type feller buncher itself never went away. It remains a major machine category used in timber operations around the world, a lasting testament to Nelson and Vicina's recognition that one design does not fit all forests. Number 8. The John Deere 743 Tree Harvester. In 1977, John Deere unveiled a machine that was so ambitious it seemed to belong in the next decade rather than the one it appeared in. They called it the 743 Tree Harvester. The 743 combined the speed of rubber tires with the extended reach of a hydraulic boom, a combination that allowed a single operator to fell a tree and then immediately reach for another without moving the machine. In practical terms, this meant the 743 could harvest 2 trees per minute, continuously, from a single machine with a single operator, That rate was nearly impossible to achieve with manual crews, and the fact that a wheeled machine with a boom could sustain it while also providing the operator with a protected cab, ergonomic controls, and consistent positioning relative to the target trees was a genuine engineering achievement. The 743 paved the way for what we now call the modern forest harvester, a machine category that would evolve through the 1980s and 1990s into the fully automated computer-assisted harvesters used in Scandinavian and Canadian forests today. Those modern machines can fell a tree, strip all its branches, cut it to specified lengths, and stack it in sorted piles, all in about 30 seconds per tree. That lineage runs directly through the 743. Number 9. The Pika self-propelled harvesters. While North American manufacturers were building bigger and more powerful machines for full tree logging systems, a Finnish inventor named Sakari Pinomäki was thinking about the problem differently. In the early 1970s, Pinomäki introduced a self-propelled harvester under his brand Pika that represented the first practical design of what is now recognized as the modern single-grip harvester concept. The single-grip harvester is a machine with one articulated boom arm carrying a specialized head that can simultaneously grip the tree, cut it at the base, strip its branches as the tree passes through rollers, and cut it into specified lengths, all without the operator repositioning or the machine moving. One grip, complete processing. This was the cut-to-length system, the methodology where trees are processed into usable logs right at the stump, rather than being transported to a central roadside processor. The logs are then carried out of the forest by a separate machine called a forwarder. Pinomäki's Pika was not a polished commercial product in the way that major manufacturers' machines were, but it introduced the design architecture that the Scandinavian forestry equipment industry, particularly companies like Ponsse and SP Maskiner, would refine and commercialize through the late 1970s and 90s. SP Maskiner showed the first commercially practical single-grip harvester in the early 1980s in Sweden, and from there the concept spread globally. Today, cut-to-length harvesting is the dominant method in Scandinavian, Finnish, and much of Canadian forestry, a legacy that traces directly back to Pinomäki's prototype work in the early 90s. Number 10. The Koehring Waterous disc saw feller buncher head. Our final machine is not a full piece of equipment on its own. It is a component that changed everything it was attached to. And in terms of impact on how timber is actually cut, nothing between 1940 and 1990 was more transformative. The disc saw feller buncher head was developed by engineer John Deere while working at Koehring Waterous in Brantford, Ontario, Canada in the early 1980s. Before Deere's disc saw head, feller bunchers used shear-type cutting heads, essentially giant hydraulic scissors that snapped trees off at the base. Shear heads had a critical problem. When a shear closes on wood, it splinters the base of the cut, and splintered wood cannot be used for lumber. Shear-cut logs are suitable for pulpwood and chips, but not for dimensional lumber production. This meant that for decades, feller bunchers were largely restricted to the pulpwood market. Deere's disc saw head used a large rotating circular saw blade instead of shears. The disc saw sliced through the tree cleanly, leaving a smooth flat cut with zero splintering, which meant the logs it produced were suitable for high-value lumber production, not just paper pulp. The impact was immediate and enormous. Suddenly, feller bunchers could operate in solid wood timber markets, not just pulpwood operations. The speed advantage of the buncher, compared to manual chainsaw felling, was now available to lumber producers who had previously been excluded from mechanized felling. Deere's saw head also allowed for continuous cutting. Unlike shears, which must open and close between each tree, a disc saw can move from tree to tree without stopping its rotation, increasing cycle speed dramatically. Industry observers who watched these machines in operation described them as capable of being breathtakingly quick. When Timberjack acquired the construction equipment portion of Koehring in 1988, Deere found himself without a job, but his design was already embedded in the industry. He subsequently contributed to the founding of Tigercat, which built on the disc saw concept to create drive-to-tree feller buncher designs that became dominant in the American Southeast market through the 1990s and beyond. The Koehring disc saw head is arguably the most consequential single engineering innovation in forest harvesting between 1940. It unlocked markets, multiplied productivity, and made feller bunchers the central machines of industrial timber harvesting worldwide. If you found this history as fascinating as we did, hit subscribe. There's more machine history coming. And trust us, the next one is equally incredible.